So let's start with epidemiology. So in epidemiology, there are certain terminologies, and especially the 2 by 2 table and sensitivity, specificity, and all those kind of stuff. So we will try to touch all those definitions and try to understand like what exactly it means. And also, I highly recommend if all of you can have like a pen or paper or pencil, so we can, learn how to draw that 2 by 2 table, because sometime in the MCQs they are asking questions and we have very less time, like 75 seconds to answer the question. So it will be like beneficial if we know how to draw it. So uh, the first thing, if you all want, and you can have like the pen and paper with you. So the first thing, we can just draw our 2 by 2 table, and then we will study like what exactly it is. So basically in 2 by 2 table, uh, how we draw it, it's just because
Yes.
this is the test, right? So you guys are
Yeah,
like,
the above one is test and the left side is disease, present or absent.
yeah. So we just mark it like this, and now the top two are disease and then no disease, right? Kind of like this, disease and no disease. And then these are here, it is test. So suppose any test we are doing, it is positive, any test we are doing, it is negative. So now this is the test we are doing. Why we are doing this test? To know like how sensitive this test is or how specific this test is. So how we will judge that? So on this top column we have our true positive. So what are these true positive people? We will see it. And then here we have true negative. So basically the people who have the disease and the test result is positive, those are our true positive. The people who are negative, have the test negative and the disease negative. So these are like the main ones: true positive, true negative. But the test can be wrong, right? So some people can be positive and they don't have the disease. Some people can be negative and they have the disease. So that's why any test is not 100% specific and not 100% sensitive, right? So true positive, true negative, and then here we have false positive, like positive both on top, but here we have false positive. So what are false positive? These are the people who tested positive but they actually don't have the disease. And here we have the false negative. So these are the people who have who tested negative, but they actually have the disease. So that's why they are false negative. So if we want the test to be like a perfect test, then it should be 100 here, 100 here. Like all test is detecting all true negative, all true positive. There is no false, no false. But actually it's not happening. So there are false also present, right? So this is basically the 2 by 2 table, that how we draw it. So everyone good with this table?
Yes, perfect.
Good. So true positive, true
Yes.
negative. Good. And then false positive, false negative. Now we will see what is sensitivity and what is specificity. So sensitivity is basically, like, I just remember, like, I was watching some video, it was like this, like if you are more sensitive in life, so there are many times when you go down, like, kind of. So sensitivity is going down like this. And then specific, if you are more specific about in your life in anything, you go up. So specificity is like this, right? So the sensitivity is upward to downward. So TP over TP plus FN. So that is the sensitivity. So like this number divided by this whole. So TP over TP plus FN. And what is the specificity? Specificity is going up. So always wherever the arrow is going, we start from here. Suppose arrow is coming down, so we start from this thing. So arrow is going down, so TP over FN, right? And here if it is going up, then it is TN over Tn plus Fp, like Tn plus all these total number, and here Tp over all this total number. So this is our, sorry, this is our sensitivity, this is our specificity. So everyone good with sensitivity and specificity so
Yes.
far? Good.
Yeah.
So now the other thing about this table is, and also like when we put the numbers and everything, then our these two numbers should be equal to here. Like supposingly randomly, if I'm writing any number, like if I'm writing 80 here, and if I'm writing suppose 20 here, so these both should be equal to like the whole number that they are giving us, like it should be 100. So similarly these two numbers should be equal to here, these two should be here, these two should be here, so it should be like this. So now we have done the, sorry, sensitivity, specificity, and this table. And now what is the other thing from this table we have to learn is this arrow.
Positive predictive value and negative predictive value.
Yeah, and then this arrow that is going down here. So this is the positive predictive value. So positive predictive value is TP over TP plus FP, like TP over all this thing, right? And what is actually the positive predictive value? This is basically like if the test is positive, then what are the chances that the patient has the disease? So basically that is the positive predictive value. And similarly here it is going back, like positive goes front, negative goes back. So here, if the test is negative, so what are the chances that the patient have the actually doesn't have the disease, right? So that is Tn divided by this whole thing, Tn plus Fn. So these are basic the things for the sensitivity and the specificity. So I mean, it's the table is so messed up, but anyways. So now we will see the actual definitions about the sensitivity and the specificity. So for the sensitivity, they say snout. So what is snout means? The sensitive test to rule out a hypothesis. Note that the sensitive test have very few false negatives. If you get a negative test, it is likely a true negative. I mean, these lines are so complicated, but like snout means a sensitive test will detect all the like the positive in the population, but snout means n, if it is negative, it ruled out the disease. So n is like negative. So sensitivity is the test is negative, it ruled out the disease. So whoever in our sensitive in the group are negative, it means it's ruling out the disease. So does it make sense?
Yeah.
Okay. And then the specificity, the abbreviation is SPIN. Like if the specific test is positive, then it rules in the disease. So basically that's SPIN is. So if the test is positive, it means the patient have the disease. So specific test to rule in a hypothesis. Note that the specific test have very few false positive. If you get a positive test, it is likely a true positive. So that is the thing, like specific test is specific for the disease and it rules in the disease, and sensitive test rules out the disease, like what whoever is negative, it kind of rule out. So now a defined collection of individual regions, institutions, this is just the definition of epidemiology, I think. So, what is the sample? A collection, sorry, a selection of individuals from a population is the sample. So types, it can be random, systemic, stratified. Population is divided into subgroups, cluster, convenience. So all these are the different sample types. Now the sample size, increase the sample size, increase the statistic precision of the observed estimate, resulting in a more narrow confidence interval. So basically it means like the more there is like more sample size increases, then it is like there are more people to have a test on, so it is statistically significant. So increase the sample size, decrease the probability of type 1 and type 2 errors, and increase the sample size does not alter the risk of bias and confounding. So what is bias? Systemic error leading to incorrect estimate of true association between exposure and outcome. So basically bias is the error, like when we are doing the test, so between exposure and outcome. So then the different type of errors is the bias. So there are different type of bias. So for example, selection bias, a systemic error in the recruitment or retention of study participants. So selection bias is the error basically in selection. Then Parkinson's bias is the case control using hospitalized controls as they may not be a representative sample of population due to complexity. So basically Parkinson bias is always usually in the hospital.
Hospitals.
So yeah, so hospital admission. So you are not taking all the population. You are just taking the sample of hospitalized patients. So that is your Parkinson bias. Then non-response bias occurs when participants differ from non-participants in a study. So in that, those who volunteer may be healthier. So this is the non-response. Then loss to follow-up occurs when dropout rates differ between study groups and patients who dropped out are different from those who did not. So they cannot complete the study, they are dropping off. So information bias, the way in which information is collected about study participants is inadequate. And then there is recall bias, like the individual with disease may be more likely to incorrectly recall belief they were exposed to. So they don't have like the sharp memory, so they cannot give exactly the what happened, they cannot recall it. So that is the recall bias. And interviewer bias occurs when interviews are unblinded to outcome status, and this knowledge bias their behavior. So and then the observer bias occurs when knowledge of exposure status bias the observer towards a diagnosis. This occurs more commonly with the subjective diagnosis like those found in psychiatry. So these are all the different form of bias. So now what is the confounder? That is actually a variable that is related to both exposure and outcome, but it is not a mediator in the exposure outcome relationship. So there are two main things, exposure and then the outcome. So this confounder is like in between these two, connecting these two.
Is the confounder a risk factor?
It is, I think, kind of risk factor,
Yeah,
but
because it's saying it is related to both the exposure and outcome, but it is not mediator in the, like it don't mediate, but it is like related to both the exposure and outcome.
yeah, yeah. So it distorts the estimated effect of exposure if not accounted for in the study design analysis. For example, late maternal age could be a confounder in an investigation of birth order more than 4 and risk of developing trisomy 21. So late maternal age is example. And then randomization, stratification, matching, regression, remodeling can help minimize the confounding effect. So these are the strategies to adapt to minimize the confounding effects in any studies. So now this is the interpreting test results. So this is our 2 by 2 table that we just did. True positive, true negative, false positive, false negative. So sensitivity is this one, and then specificity is this table. And then what is the likelihood ratio? Likelihood ratio give of a given test results would be expected in a patient with disease compared with the likelihood the same result would be expected in a patient without the disease. So likelihood ratio positive and then negative. So likelihood ratio positive means how much the probability of disease increase if the test is positive. So it is basically if the test is positive, then how there is how much chances like it will be actually the disease will be present. And then likelihood ratio negative indicate how much probability of the disease decreases if the test is negative. So positive and negative. So this is just the formula. The positive is in sensitivity divided by 1 minus specificity. And then likelihood ratio negative means 1 minus sensitivity divided by specificity. So we just have to remember these formulas, I think. And then the positive predictive value is the proportion of people with a positive test who have the disease, the ones that we see here. If we go from here to here, it is positive predictive value and then negative predictive value. And then this is just, I think they are giving one example, advanced neoplasia. So this is the sensitivity. So how they calculate the sensitivity, 68 divided by these both numbers, like 68 divided by 284, and these both numbers should be equal to this. So 68 divided by 284, 23% sensitive. And then specificity is this number divided by this total. So 93 specificity. And then these are the likelihood and negative predictive value and positive. So these formulas, I think we just have to remember, so at least we know how to calculate. So what is actually sensitivity? So this is just the data of FOBT test in advanced colon cancer. So this is just the example. So it's a proportion of people with disease who have a positive test. So as we have seen, the sensitive test, Snout. So negative sensitive test rule out the disease. So if it is like sensitive test and it is positive, that means the people have that disease. And a specific proportion of people without disease who have a negative test. That is the spin that we studied before. And what is pre-test probability? Probability that a particular patient have a given disease before a test assessment results are known. So that is just pre-test probability. And post-test probability, a revision of probability of disease after a patient has been interviewed, examined, tested. So calculation process can be explicit using results from epidemiological studies and all those things. The post-test probability from clinical examination is the basis of consideration when ordering diagnostic test or imaging studies. And after each iteration, the resultant post-test probability become pre-test probability when considering new investigations. So sensitivity and specificity are both characteristics of the test, as we already know. And then likelihood ratio depends on the test characteristics, not the prevalence. Likelihood ratio. And then positive predictive value and negative predictive value depends on the prevalence of the disease in the population. So this is important, like PPV and NPV depends on the prevalence of the disease. And these are just the test characteristics. So this efficiency, these are just, I think, the definitions, and this is just the graph showing. And this is the example they are showing for the case control. So for this case control and cohort study and all this, we will see what are the definitions of all these. So what is number needed to treat? A number of patients who need to be treated to achieve one additional favorable outcome. Only one of many factors that should be taken into account in clinical or health system decision making. Must take into account cost, ease, feasibility of intervention. A condition with death as a potential outcome can have a higher number to treat as compared to intervention to prevent an outcome with low morbidity, in which a low number to treat would be necessary. So number to treat is basically just how many uh, patients to be treated to have one additional favorable outcome. So this is number to treat. And then what is number needed to harm? Number of patients who, if they have received the experimental treatment, would lead to one additional patient being harmed compared with patients who received the controlled treatment. So this is just like to know the adverse effect. Like for example, in a given population, like if they are researching about angioplasty, so angioplasty, many people are getting benefit, but then number needing to harm, like if there is side effect like bleeding or anything like that, then how many people are treated for, then to to see like what how many people are harmed. So that is basically number needed to harm. So adherence is formally compliance, degree to which a patient's behavior and lifestyle concords with recommendation of healthcare providers, the extent to which a patient takes medication. Anyways, this is beware, do not be swayed by a large relative risk or odd ratio as it may appear to be large if event rate is small to begin with. In these cases, AR is more important. A drug which lowers an event which occurs in 0.1% population to 0.05 can. So we will study the relative risk and attributable risk, then we'll see what is it. So this is number needed to treat. I think they have this website. So what are different types of study? So they are qualitative and quantitative. So we will see this one, the chart. So basically there are like observational study and then experimental study. So were exposure assigned by investigator? Yes, no. So in the observational study, the investigator is not assigning the exposure and all thing because it is only observation. And the experimental study, they are assigning the groups. So basically, the experimental study is randomized control trial and non-randomized control trial according to the groups that they are aligning. So the experimental study are these two. And then the observational study is testing a hypothesis. Yes, analytical study. So basically these three are the studies that are the main ones in the observational study. Cohort, case control, and cross-sectional. So all these three are observational and the experimental is these two. So now we will see what are the, and the other one is the descriptive study. I think these three are more important. So basically what is the case control and cross-sectional and cohort study? I think UWorld has like a very good chart. I'll see if I can. Yeah, so this was just the sensitivity and specificity that we were doing before, but prevalence and all this. So yeah, this one. This is just the UWorld notes that is also shared in the group. So these are the type of different studies. So we will see from here and then we can go to the Toronto notes. So these are the main, so this is present, future and past. So we will check like which studies we are going to the past, which we are going to future and which one we are doing in the present. So this cross-sectional one, uh, it is just in the present because this is just we are doing just in one time. So we are not comparing anything in the future, we are not comparing anything in the past. This is just for one point we are comparing. So basically in this one there are usually like the questionnaire and surveys and all those. So this is risk factor positive and risk factor negative, but at given one point we are not checking any other things. So now what are the other ones? So this one, the case control. In the case control, we are going backward. So we are starting from present and going backward. And what we are checking the disease cases and non-disease cases. So these are already present. They have the disease or they don't have the disease. And then we are going backward and we are comparing the risk factor frequency. Like the disease patients have the risk factor or the non-disease patient doesn't have the risk factor. For example, if there is like a skin cancer, patient with skin cancer, patient without skin cancer. So we go back and then we check whether there was like sun exposure or like any other risk factor present or not. So this one is case control study. And then what is the, so this is the cohort study. So basically cohort study, they have divided into the prospective cohort that is going forward in the future and retrospective cohort that is basically going backward. But usually in the cohort, we are doing the prospective, like we are going forward. So what is actually the cohort study? It is opposite to the case control one, because in case control, we already have the patient with disease and no disease, and we are going backward to check the risk factor. And in the cohort study, it is opposite. We are checking the people who have the risk factor and who don't have the risk factor, and then we follow them along the course in the future, and then we will see whether they get the disease or not. They didn't get the disease. So basically, this is the cohort, and then the case control. It is like kind of opposite. And then the other type of cohort, they are saying the retrospective cohort. So they are review the past records. So they go in the past and review records. But I think this one, the prospective one, is like more common and more important. And then the last one is clinical trials, treatment group and control group, and then compare the outcomes. So these are basically the different types of study, like the observation study. And this is all the, I think, definitions they are giving. So, so now we will see what's written here. So observational study involved neither the manipulation of the exposure or the study participant. There are two main types of observational: descriptive and analytical, that we see in the chart. So descriptive is basically rate of disease with respect to person, place, time, frequency, and trends. Include case reports, one person or event, or all this. This is descriptive. And in the analytical one, observational studies used to test a specific hypothesis, includes ecological studies, cohort, case control, cross-sectional. So these three are the important ones. They are in the analytical studies. So observational studies are basically ecological, cross-sectional, case control, cohort. So ecological is basically units of analysis or population or groups of people rather than individuals. And aggregated, basically ecological, they are doing in groups. And then in cross-sectional, we have seen sample of population, use individual data and all that. It is usually in one time. Collection information from each person at one particular time. So this is important for cross-sectional, at one particular time. And tabulate the number in groups and make the tables and all that process. But it is at given one time. And in the case control, as we have already studied, we are checking the patients with the disease, without the disease, and then going back and check the risk factors. So samples of a group of people who already have a particular outcome, we know they have the disease, compare them to similar group without the outcome, that are the control group. So case control, case that have the disease, control they don't have the disease. So we already know the people have the disease or not the disease. Two or more samples of individuals with and without the outcome of interest. So we are taking two samples. And then select sample of cases of a specific disease during a specific time frame, representative of spectrum and all this. They have written here so much. To minimize risk of bias, may select more than one control group or match controls to cases. And these are just the examples. So it is often, what are the advantage? This is often used when disease in population is rare, less than 10% of population, due to increased efficiency, or when time to develop disease is long. So case control advantages can check the rare diseases. But the disadvantage is recall bias, confounding, selection bias, control, all these biases can be. And what are the advantage of the cross-sectional? Determine association between variables, quick and use fewer resources, survey with best, survey and questionnaire, and it is like quick because they are doing at one point of time. So if you want to know the fast results and everything. But what are the disadvantage? Does not allow for assessment of temporal relationship or offer strong evidence of causation, and all confounding bias and everything. So study that examine the distribution of BMI by age in Ontario at a particular point in time. So this is the example. At one point, if you're checking the BMI of different age group, so that is the example of cross-sectional. So now what are the cohort? Cohort studies were like we are following a group of people and then with the risk factors, and then we are checking whether they get the disease or not. So subjects are sampled and as a group classified on the basis of presence or absence or exposure. So basically risk factors, according to risk factors we classify both groups. One or more cohorts. Cohort is the group of people with common characteristics, year of birth, region. So basically we are dividing the cohorts um, according to their common characteristics, and then divide into measured exposed versus unexposed. So that's how we are making the cohorts. and collect information on factors from all persons at the beginning of the study. Subjects are followed for a specific period of time to determine development of disease. So throughout the time we are following them, and then measuring from exposure at present to the future outcome. So this is the prospective and retrospective that we just checked in the UWorld chart. So what is the advantage of cohort study? Shows an association between risk factor and outcome. So that's the main point of it. And then stronger evidence for causation, can consider a variety of exposure and outcome. So the disadvantage, confounding may occur due to individual self-selecting exposure. Unknown, unmeasured factors are associated. So we are like, suppose we are checking one risk factor and the outcome of the disease, but there can be the confounders, like the other risk factors can be present that the patient have not mentioned or it is not included in the study. So that are the factors. And then cost and duration is the main of time needed to follow cohorts, because you are following them for a long period of time. So it's like kind of expensive study, and selection bias and all that can happen. Now, what is the example of famous cohort study is the Framingham Heart Study, which assessed the long-term cardiovascular risk of diet, exercise. So this was like the example of the cohort study. So everyone okay with the uh, study design so far? So then we can do the next one, experimental study design. This is the randomized control trial. The one that we see in the chart, randomized and then non-randomized. So this one is the participants are assigned by random allocation to two or more groups, one of which is the control group and the other group is the other one, control. So case randomized. So participants, individuals are selected using explicit inclusion-exclusion criteria, and recruitment targets are guided by sample size calculations. So studies being sampling subjects based on outcome. So this is disease, no disease, cases, control, and this is the exposure, exposed, not exposed. So this is just the chart of the case control study. Like we all already know the people have disease or no disease, and then we are going back and checking the risk factors. So the disease patients are exposed, no disease patients are not exposed. So this is just the thing, and this is just the chart for cohort study. So study begins exposed, unexposed, because in the cohort study we are following a group of cohort and then seeing if the disease is present or not. So with time we see the exposed ones get the disease and the not exposed doesn't get the disease. So this is kind of like opposite, cohort and case control are kind of opposite to each other. So here in the randomized control trial, what is the advantage? This is the gold standard of all the studies upon which practice of EBM is founded. So the gold standard of all the studied is randomized control trial. That one is the main one. Provide the strongest evidence of effectiveness of intervention. Threats to validity are minimized with sufficient sample size and appropriate randomization. So with appropriate randomization, the it can be more beneficial. And randomization is one of the few methods that can eliminate confounding, including unmeasured confounders. So that's why it's like a gold standard study. So it will minimize all the confounders. So what are the disadvantages? Some exposures are not amenable to randomization, cannot randomize participants to poverty and all these smoking, like it is good for randomization, but disadvantages like some exposures are not like modifiable, like for example these ones. So that's why it is that is the disadvantage, and can be difficult to randomly allocate groups, communities, neighborhoods, difficult to study rare events. So it is not good for rare events, and require extremely large sample size, contamination, and loss to follow up. So these are all the disadvantage of the randomized control trial. So, uh, anyone want to study from, like, read from here?